In this video, we're going to interpret the relationship between the velocity function and the acceleration function. It says the position of a hummingbird flying along a straight line is given by the function s of t equals t cubed over 3 minus 7 t squared over 2 plus 10t, where t is greater than or equal to 0 is measured in seconds and s is measured in yards. At what intervals is the hummingbird speeding up? So anytime you're speeding up, you're either going forward and you're accelerating, or you're going backwards and you're decelerating. So what we want to do is we want to find out when our velocity and our acceleration are both positive, or when our velocity and acceleration are both negative. Now the first thing I'm going to do is I'm going to take the derivative of each of these, or of this function, to find the velocity equation. So v of t is going to equal to s prime of t. So we end up with, when we take this derivative here, we get 3t squared over 3, which the 3's cancel, so you get t squared, minus, when I bring the 2 to the front, the 2's would cancel, so I'd end up with minus 7t plus 10. And then we're going to also find the derivative of that for the acceleration, because we know that's v prime of t, which is equal to s double prime. And when we take the double prime of this equation, that'd be 2t minus 7. Now I want to find out when the velocity is 0 and when the acceleration is 0, because that's when we could have some changes in velocity from positive to negative, and same thing for acceleration. So we're going to say, when is the velocity 0 for this equation? And then I'm going to factor this by saying 0 is equal to, I can get t minus 5, t minus 2. ZPP tells me that my times would be t minus 5 equals 0, or t minus 2 equals 0. So I get t is equal to 5, or t is equal to 2. Let's do the same thing for acceleration. I say 0 equals 2t minus 7. Add the 7 over, I get 7 equals 2t. Divide by 2, I get 7 over 2 is t, which would be 3.5. So 3.5 seconds, 2 seconds, and 5 seconds. Now I'm going to draw the number line here. And I want to see, starting at 0 seconds, is my velocity positive or negative in these different areas? So I'm looking between 0 and 2, 2 and 5, and 5 to infinity. What is the velocity? So I'm going to plug in 1 into my velocity equation, which would be t squared minus 7t plus 10. So I'm going to say 1 squared minus 7 times 1 plus 10. Well, this would be 1, that'd be 11 total, minus the 7, so I end up with a positive number here. And then, if I do the same thing with, let's call it 3 squared minus 7 times 3 plus 10. Well, now I get negative 21 plus 10 would be negative 11 plus the 9, I'm still negative. So this is negative in that region. Now let's go 6 squared minus 7 times 6 plus 10. Well, I get negative 42 here. This is 36, but this makes 46, so I'm actually positive here as well. So my velocity goes from positive to positive, and it switches at 2 and 5 seconds. Let's look at the acceleration. 3.5 seconds. Let's check from 0 to 3.5, and then obviously 3.5 to infinity. So we're going to check 1. If I plug in 1 here, I get 2 times 1, which is 2, minus 7, that's negative. So acceleration is negative in that region. And let's pick out 5 here. So 2 times 5 is 10, minus 7 is positive, so it's 3 positive. So now that I know where my acceleration, what my values for acceleration are, and then also my values for the velocity, let's map them on the same number line. So I'm going to break this up by going 0 to 2 to 3.5 to 5 to infinity. And then on the top, I'll map the velocity. On the bottom, I'll map the acceleration. So the velocity is going to go plus. It'll be plus from 2 to 3.5. No, it won't be. It'll be negative from 2 to 3.5. It'll be negative from 3.5 to 5, right? Because it's negative 2 to 5. And then it's positive afterwards. And then for my acceleration, it's going to be negative from 0 to 3.5. So we're going to go negative here, and then positive afterwards. And remember, I'm looking for when it says that the hummingbird is speeding up. Well, it's speeding up when the velocity is positive and the acceleration is positive. And it's speeding up when the velocity is negative going backwards and the acceleration is negative. So it's speeding up in these two regions. So what we can say is that from 2 to 3.5 seconds, union 5 to infinity, that the hummingbird is speeding up.